So we're going to hear a great deal about what is the process and the evaluation of product recalls. How does that happen? And I do appreciate George and his co-authors for providing this insight kind of behind the scenes, and especially with his experience in the medical device industry. I think we'll have a good inside look. So welcome George Wall here.
Thank you very much. Okay, so thank you for coming. And one of my co-authors, Ujjal, is here. Caitlin could not make it. But I appreciate the chance to talk to you about recalls. Hopefully I won't bore you too much. I'm going to try to tell stories to make it as interesting as possible, because I have a few recall stories I can share, and I can also share how those turned into papers. So my two co-authors, Katie and Ujjal, were a huge part of writing this tutorial, and a big part of several of the papers that I'm going to talk about. So what I'm going to do is I'm going to very briefly talk about what a recall actually is, in case you're not familiar, and why I think it's worth studying. I'm going to present the three recall research dimensions. I'm going to talk about how, in a few cases, we've been able to turn some real stories into studies. I'm going to go into the regulators. There are three main regulators that manage recalls: the FDA, the National Highway Traffic Safety Administration, and the Consumer Product Safety Commission. I'm going to go through each of those and compare them. You have a clicker? Oh, that'd be great. I'm going to talk about some challenges. We're just going to add a clicker here so I can. Thank you very much. And then I'll talk about some future research opportunities. Okay, so when you think about what a recall actually is and why it's worth studying, it really depends on who you ask. And so if you ask the FDA, their definition, when they oversee pharmaceutical and medical device recalls, their definition, and I bolded the two things that I think distinguish their definition from others, that it's a voluntary action by firms to protect the public health from products that may be harmful. Another major recall regulator is the National Highway Traffic Safety Administration, and they oversee cars. An interesting difference is that they have this language difference in there bolded that either a manufacturer or NHTSA determines that a product is not safe and it needs to come off the market. And that's not just a random difference. That's a very purposeful difference that these regulators are making, that FDA basically trusts the firms to take action when they need to. NHTSA, not as much. I'm going to talk a little bit about that as I get towards the end of this talk on regulator differences. The Consumer Product Safety Commission does almost everything else. And so it can be strollers or blinds, toys, dehumidifiers that can burn up. And their definition is a little less precise, a little longer. I would say, as I'm going to talk about regulators at the end, that the CPSC is probably the one organization that is in most need of reform. The way they're organized, it's less, there's less clear control of the organization as the FDA and NHTSA are. They're made up of a bunch of commissioners. They have very poor relationships with manufacturers, and because they oversee such a diverse set of products, they don't have a very strong ability to manage their quality. So I'll tell a quick story on what it means to me. And this is how I first got involved in, are you not hearing this? Oh, okay. This is how I first got involved in recalls. And so my first job, I was actually in the Navy before I went into business, before I came into academia. My first job in the Navy was at Guidant Corporation, and I managed a production line that looked exactly like this. So we were kind of COVID gowned up all the time with hairnets and booties and gloves. And that could easily have been a production line picture from where I worked. And the first product that we manufactured was called the Pulsar pacemaker. And it's a rather old one, but it was Guidant's flagship pacemaker at the time I started. So in case you're not familiar, a pacemaker gets inserted right under the skin up near your chest, and then the leads are placed into the base of the heart, and they're actually run into your heart, and they're screwed into the base of the heart. It's a very invasive type of product, but it can keep you alive if you're pacemaker dependent. and our customers for this product generally were. The thing that makes this story interesting, this is the first recall I've ever experienced, is the integrated circuits on this pacemaker went like this. So an IC, if you're not familiar, looks like this, and these are the leads that are soldered onto the motherboard. And the way you compete in a pacemaker is by size. And so the goal was to make this pacemaker as small as absolutely possible. So what the designers of this device did is they triple stacked their integrated circuits. What that means is, as you can see here, there's actually solder pads underneath this integrated circuit. So there were 3 chips stacked on top of each other to save space so that you needed less real estate, kind of square footage, and you could have them very tightly on top of each other. So they're the SRAM, the digital, and the mixed mode chip were all on top of each other. Now, it was a pretty ingenious design, and I had just started, so I didn't know what any of this meant on this production line. And what ended up happening is they issued a recall, and this dates me because this is the actual recall warning from that actual recall, dated March 1999. But the leads from the chips that are underneath this one were touching the solder pads of the other chips, and it was shorting the pacemaker out. And so a pacemaker needs to last about 6 years. These were lasting 6 months. The battery would drain, and a customer that was pacemaker dependent would hear a beep, and that beep meant you're not getting pacing technology, and you're going to die if your heart starts to slow down. And so it was a pretty massive recall, and I remember sitting in this huge conference room. Our vice president of manufacturing called a meeting, and I had been out of the military like a week. I didn't know what the word recall really meant when it came to business. I was sitting on a table because there were no chairs left, and she's explaining how we're going to have to recall every pulsar that's been made, and we've got to put this insulator on the back underneath side of all these chips to prevent them from shorting each other out. And I was fascinated to watch the reaction of the supervisors, the manufacturers, the directors, the VPs, how this changed things on the production line quite dramatically, how it changed all the reworking of these devices, and it began my kind of fascination with what a recall can actually do to a company. So with that as the groundwork, I'm going to explain to you the dimensions of recall research. And these dimensions, I would say, I believe my advisor and I, Rasha Shah, kind of hashed these out during my PhD time, and it's kind of laid the groundwork for the research that my co-authors and I do. So you basically have a product being designed or manufactured, and in that process, you have problems that come to the surface. In that example I just gave, it was a design flaw that led to that device shorting out prematurely and leading to a systemic product defect. The word systemic is actually kind of important because people don't recall for random failures, for one-off failures. They're recalled when there's a systemic pattern of failures that have the same root cause that need to be acted upon in the market. And so this is really the first dimension, which is either the cause or the leading indicator. And there's a big difference. I've done some causal research with my co-authors, but we also do research on the leading indicator. So not studying what caused the problem in the first place, but what may be signaling that a recall is on the horizon. Once you have a systemic product defect, you have this decision to recall, which is not always straightforward. I'm going to talk about this quite a bit, that it's my favorite area to study is this recall decision. There's a lot of discretion in this decision. And there's a lot of interesting biases that are at play when managers are struggling to make this decision. So that's the second dimension. And the third is what comes after. And so recalls do damage to companies, to investors, to customers, to relationships with regulators and suppliers. They affect competitors. There's a whole host of aspects and stakeholders that are affected by recall. And this is really the third dimension, which is recall effects. And I would say that every paper that's tied somehow to a recall could be categorized into one of these 3 buckets. Please stop me at any point if you have any questions. Since there's not many of us, we've got plenty of time, so I'd be glad to stop if you have a question. So now I'm going to talk about a few more stories. I'm going to start with my favorite one that I was very involved in. I've had to make several recall decisions, and I've not made some when I probably should have. And so a lot of this research is very personal for me, and this one in particular, this is my favorite recall story. So does anybody know what your left atrial appendage is? You do. Interesting. Well, then you're going to know what I'm talking about. Okay. Do you want to tell, what is your left atrial appendage?
Just don't say anything too exciting.
Okay. So your left atrial appendage is like your appendix of your heart. It's in the top left-hand corner of your heart, in your left atrium. And when I say it's like your appendix for your heart, that means it doesn't really have much of a purpose. It's a little pouch that hangs off the end of the heart. The reason it matters is that if you've had a stroke in the past, blood can clot in your left atrial appendage, and those clots can then go straight to your brain, cause a stroke, and kill you. So for stroke patients, doctors, until this device I'm going to show you, would cut open your chest and sew off the left atrial appendage and close it off, prevent blood from going in there so that it couldn't kill you. But as you can see, there's this device coming in here, and when I was at my second company, AGA Medical Corporation, we came up with the device, certainly not me. I manufactured it, but other very smart people, much smarter than I, designed this. So this is called the Amplatzer cardiac plug. And what this device does is you can see there are hooks, there's polyester fabric sewn in here. It's a nitinol wire memory device. So nitinol wire, which a lot of heart devices are made off of. You shape it in a mold, you bake it at 1,000 degrees Fahrenheit for like 15 minutes, and then once it's been baked like that, it'll never lose that shape again. That allows you to pull it into a catheter, insert it intravenously through the groin, and then right up into the heart, and when you push it out of the catheter, it regains that shape that you baked it in. And so this device goes into your heart, and it anchors itself in the left atrial appendage. And the fabric material is there to slow down the blood flow or occlude the blood flow. As that blood slows down and kind of catches the fabric, eventually the tissue responds to that fabric and it'll grow right over this device and it'll be there for the rest of your life, and then the appendage will atrophy and you can't get a blood clot from it. So our company made this device, and one unique thing about this device is that it has two end screws. The female end screws look like this, and they're identical on either side. So the cable is screwed on to the top and to the bottom. It's a pretty complicated procedure to implant it. But I was in the design review when I was the manufacturing director at the time, and the design director was presenting this at a design gate meeting with the CEO was there, and we were talking about getting it to production. And I asked the question, so he mentioned that these two screws were identical. And so my operators that worked for me were supposed to package this device, attach it to the cable, put it into a pouch, and it gets sterilized, attached to the cable. So I asked, what if my operators attach it upside down? Since the female end screws are identical, this is right side up, but you could attach this screw to that cable and attach it upside down. And so I said, what if they manufacture it upside down and put it in the package that way? And this design director said, I'm sure they won't do that, just train them not to do that. And for me, that was a great indicator, this individual has no idea what it's like to run a production line. That's not how you prevent errors. I had a production line of 150 people, many of them English wasn't their first language, and so just training them isn't a good error-proof solution. So I asked him what would happen if they packaged it upside down, and he said, well, then the physicians aren't familiar with this device because this is brand new, and so they won't know, and they'll implant it upside down, and these hooks, instead of anchoring into the side of the left atrial appendage when the doctor tries to set the device, they'll push the device out. The hooks will grab the side of the appendage and rip it off the heart. The person will be dead in about 30 seconds. And I'm like, okay, this is important, then we don't want to have this happen. So instead of just saying, let's train the operators, let's change the dimensions of these screws so that you can't package it upside down. That was my suggestion in the design review, maybe 2 months before we went to product launch. And the CEO, and this ties into some research I'm going to talk about, he was very incentivized by stock. He didn't keep it a secret that I think he had $10, $15 million in stock options tied to the company going public. And at the time, I had some IPO shares that I was excited about as well. I think I had 7,000 shares at $1, but as we got closer to going public, they did a bunch of reverse splits. I won't bore you with what that means, but that means is that people like me got a lot less money. So we went public, and I think I made 30 grand. I think he made 10 million. And so he wanted to go to launch quickly. So we launched the device without changing the end screw design. In Europe, you can get devices approved much sooner than you can in the United States. And so it was immediately approved in Europe. And because the CEO knew there was going to be risk with this product, we mandated that sales reps should be present at all implants. Well, as I was not surprised, 4 months after we launched, a sales rep was at an implant somewhere in Europe. The device was opened up and it was upside down. And the sales rep's like, yeah, don't implant this. You're going to kill the patient. And so they called the company, and then they called me, inevitably. And I said, well, production operators are going to make mistakes. I apologize. And so we recalled everything we had made that was all over Europe. And the solution, the design fix for the recall, was to change the design of the end screws so that you can't package it upside down. It was exactly what we talked about doing many months ago. So this is an example of a recall that was very preventable. It was a design mistake, but we rushed to market because we wanted the money. So kind of to put it in perspective, this thing would be manufactured for, I'm not sure, I'm sure it was proprietary at the time, but somewhere under $1,000, I think. I think we sold this in Europe for 10,000 euros or something. So, I mean, the margin on this was unbelievable. The temptation to get it out right away was really something. Okay, so that's kind of a story that I don't actually think I've tied necessarily to one specific paper, but that's kind of a motivating story that I like to tell. And now I'm going to present one paper from each of these dimensions to kind of help you understand how we've studied these recall dimensions. So this is recall causes or leading indicators. Another quick story, and I'll be fast on this one. So at Guidant in 2005, if you know anything about the story of Guidant Corporation, it actually used to be headquartered here in Indianapolis. It's a fascinating story, and it all started with this front page article in the New York Times by Barry Meyer. So a patient had died with a Prism 2 device in their heart. The device, it was a defibrillator. And so defibrillators are very serious devices. If your heart goes into atrial fibrillation, the device needs to be there, and it needs to shock you, or you could die. And so this Prism 2 device was keeping this patient, Joshua Okrop, alive. It failed to deliver therapy, and he died. His doctor knew executives at Guidant very closely, and everything I'm telling you, none of this is proprietary because this was on the front page of the New York Times for so many months. And I was a manager at Guidant at the time, a low-level manager on a different production line, so I'm able to kind of criticize this aspect because I had nothing to do with this device, thankfully. The doctor, Dr. Hauser, came to Guidant, and he recommended that they recall Prism 2 devices. And the Guidant executives at the time decided that the failure rate was at an acceptable level because these devices all get approved with some predicted failure rate. And so it wasn't failing above the predicted failure rate. The executives decided not to recall the device. Dr. Hauser went to Barry Meyer at the New York Times. Barry Meyer got very excited about this opportunity to make his name for himself. He called the executives at Guidant, and he said, I'm about to go live with this report on the front page. The night before the article got published, they recalled the device, which really didn't make the executives look very good. What that led to is this slew of attention from the FDA, and I got to observe this firsthand. It was actually really fascinating, and this attention has led to a lot of the research I do with the FDA. So the FDA did not like all this front page attention, and the Senate got involved, and the Senate kind of pushed the FDA. This is a bad company, do something about them, because we were like the number 2 seller of pacemakers and defibrillators at the time. We were a huge company. So the FDA, one of the first things they did was send in a local inspector to the plant to do a directed inspection. His name was Joe, I don't remember his last name, and he came and he gave us a clean bill of health. Potentially because maybe this wasn't a serious issue, it wasn't systemic, maybe not, and the FDA did not like that. And so then they sent in 3 national inspectors, 3 very intimidating inspectors. One was in a uniform. At the time, I didn't know the FDA could wear a uniform, but there's a uniform division of the Health and Human Services, which the FDA works for. She was intimidating, that's for sure, in her uniform. And the others were also, they were very serious people. So they came and they ripped us apart in this inspection. Every production line, including mine. And I have all these stories that I'm not going to tell today about these inspectors in my production line. My line wasn't even affected by this recall. And so that spurs a paper with my advisor, Rasha Shah, and one individual on my committee, Enno Simpson. When I was presenting my proposal to my committee, Enno mentioned that he had some data on inspections. I was talking about recalls, and he's like, I have this inspection data, and I have inspector ID numbers where you can count the number of times that an inspector has been to a plant. And I said, okay, this ties really nicely into an experience I had. This might lead to an interesting study. So what we studied is the frequency that an inspector has been to a plant and how that affects the quality of their inspection score. And the entire paper comes down to this one figure. So there are 3 categories of inspection severity at the FDA: official action, voluntary, and no action. No action is a really good score. Voluntary is medium, official is very bad. This chart tells the entire paper, and I think is why this paper got published. So if this is from the perspective of the inspector. So if I'm an inspector and I've been to your site just one time, if it's my first inspection at that plant, how do my scores relate to the hazard of a recall? So if I give you an official action, which is this, you have a high hazard of a recall. If I give you a no action or voluntary action, you have a very low hazard, and there's a statistical difference between these two here when I have my first inspection at your site. As soon as I've been at your site more than one time, these confidence intervals begin to overlap, and then the longer I'm there, the best inspection scores and the worst, they all kind of mix in together. And there's no difference between the predictability of my inspection score and the likelihood that your facility is going to have an inspection sometime in the future. So we actually got the chance to present this to the head of the medical device division at the FDA, and it was one of several papers that they were looking at that showed that they need to rotate their inspectors. And I think now they do a little bit more rotating than they used to, but the purpose of this is to say that if I'm new to your facility, my inspection is going to be highly predictive of what's coming at that plant. It's going to be a more objective inspection. And if I'm not new, the value of my inspection goes way down, because what we attributed to in the paper is excess familiarity with the facility, with the people, with the management. And this is what we saw back in this story that I was telling you, that they sent in this local inspector. Everybody knew him. He couldn't find anything necessarily that wrong with the plant until they brought in these new national inspectors. So that's my first kind of story leading to study. Now I'm going to tell you about a working paper that looks at leading indicators as well. And this gets to some grant work that my co-authors and I have had a chance to do with the FDA. The pictures of those people involved. These first 3 are Christian, HP, and Hassam were on this grant. Katie, who's a co-author on this tutorial paper, she wasn't part of the grant, but she's on this paper because she's brought a very interesting gender dimension to this paper that I'm going to talk about. So we were brainstorming with the FDA on novel predictors of drug recalls when this paper got going. And we had the idea of using online drug reviews. Our goal was to associate consumer reviews on drugs with the future likelihood of a recall. And so we thought about using WebMD. And WebMD is, if you're familiar with, it's a very popularly used online drug complaint kind of website. It's actually the most visited medical website in the world. So HP scraped WebMD. I was kind of the leader of this project, and so I got some responsibilities that were kind of painful, as I'm about to tell you. So HP understood very well how to scrape web data, and he was on this paper, and so we had a meeting with the FDA, and they're like, let's get WebMD data. So I asked HP to scrape WebMD. He did it like in one night. And so all of a sudden, we had all the data ever captured by WebMD, every consumer comment on every drug. It was fascinating. And as we developed this paper and it got further along, my colleague at the FDA, who's a director there, we were about to present the results of this paper that I'm going to show you the results of to some very senior people at the FDA. And HP, who knows a lot about scraping, he's like, we probably should get permission from WebMD. And I'm like, do you need permission to scrape data? I don't know, because I hadn't done any scraping projects. He's like, yeah, we probably should. And so I talked to my FDA colleague. I'm like, do you want to present before we get permission from WebMD? He's like, no, let's get permission. This is like a federal grant. It's probably the right way to do it. So this was because I was the leader of this project. I had the unfortunate task of kind of post hoc getting permission from WebMD to use their comments in a federal project to predict drug recalls. But I didn't have any contacts at WebMD. So I went to their main homepage. At the very bottom, it says contact us. It opened up some random contact window. And I'm thinking, this is never going to work, and that's a good thing, because I can at least say that I tried, and I never heard back. So I sent a random message. I'm like, I'm a researcher. I'm working with the FDA, and I'd like permission to use your comments on drugs in a study with the FDA. And I sent it, thinking I'm never going to hear back. And about a week later, I heard back, and I got an email from a WebMD lawyer, and they're like, we'd like to talk to you more about your request. And I'm thinking, and I didn't technically say that we had already scraped the data. I basically said I want permission to scrape the data. I left it honest and kind of a little bit vague. And so this initiated several emails back and forth with WebMD. In the end, they gave us full permission. I have this email from a WebMD lawyer that gives us permission to scrape their consumer comments. The only thing they were concerned about is that there are physician comments on WebMD.com, and those are physicians that are paid by WebMD to give consumers advice. They're like, you can't use our physician comments. And I didn't even know there were physician comments on there, so we were in the clear. We could use their comments to predict consumer drug problems. And this is what we did. So we did textual sentiment analysis on these comments. It's a fascinating study. Christian Blanco on the team had some experience in sentiment analysis. And as you can see, the way this equation works, we count the number of negative words, and we subtract the number of positive words. We divide it by the square root of the count of total words. We square root the denominator to kind of account for bias that might be created by having excessively long comments. Here's an example of a real comment. And so this is the type of stuff that you find on WebMD, where the underlined comments are negative, the bolded comment is positive, there's an amplifier, and it's italicized. And so this has a net negative sentiment of 0.78. That doesn't have a lot of meaning for you, but our purpose here was to take these random comments, turn them into scores that we could use those scores to predict drug recalls. So we captured all the comments ever made. We did some pretty sophisticated Cox proportional hazard modeling, and we behold that there's a 15% increase in the hazard of a recall for every 1 standard deviation of negative sentiment, and this is before the recall. So what it means is that consumers, based on their side effects, based on their experiences with the drug, are able to sniff out that a recall may be necessary and needed on a drug well before it occurs. So we've struggled. We did some fast track management science submissions. We've had some challenges on this paper. It's a working paper. We added Katie to the paper, and she brought a really nice dimension that I find to be the most interesting part of the paper now. We split the comments by gender because we have the comments of the person, the gender of the person making the comment, and all of the predictive power is explained by female comments. Male comments are completely useless on WebMD. And we motivate the paper in the front end by we take the same drug, we take a male comment, a female comment, and yes, we cherry-picked it for the paper, so hopefully my reviewers don't ever hear this part, but the male comment is, it's spelled wrong, it's very terse, it's like everything good so far, no side effects, and he couldn't spell something right. Then the female comment on the exact same drug is very precise, very specific, and very long. And you'd think that if one of those is going to be informative, the female one is probably going to be more informative than the male one. And it's just interesting that the male comments have absolutely no predictive value. So Katie and I have been on a couple gender papers now, so she was able to bring the science behind the differences between men and women's comments. So this isn't random and it's not stereotypical. It's actually a lot of research behind it that women have a greater sense of care, a greater sensitivity to their own personal health and the health of others, and they're more articulate and expressive in their comments. All of that feeds into why we see this result. And so there's a lot of gender management research that goes into this finding. The FDA doesn't know about the gender difference finding because that's happened after we've finished the project. But on the previous slide where it was very predictive, this is the one paper that I presented to the FDA, and I've had a chance to present several, that they were most interested in. They're like, you know what? Not only were they interested, they said, I want your state of code, I want all your row data, I want all your commands to create this model. We want all the predictions for every company in this model. Our sense is that they're using this when it comes to understanding which firms are having problems and which firms aren't, because they've got access to all of this data and all the code. Whoops. Okay, so that's the first one. The second recall dimension is the decision. So this is my favorite dimension to study because I've had the unfortunate experience of making many of these decisions, and I'm cognizant of the fact that there are so many biases at play. If you've been in one of these meetings where managers are together trying to make a decision if they should recall or not and when, it's kind of when I was in industry, I hated these meetings. Now I love looking back at them because they've motivated a lot of studies, a lot of interesting research. There are biases at play, and there are numerous biases. In the end, I think it comes down to the social benefits of pulling a product back that's potentially risky, versus the economic benefits of leaving it in the market, because these are most of the time, these are very high profit products. You want to protect consumers, but these are decisions that have significant uncertainty and risk. For instance, is the defect actually systemic, or are these random defects you're picking up? How harmful is it to customers? So there are recalls that I personally was a part of where we didn't decide to recall because we knew, look, this may not be complying specifically with one of these FDA Code of Federal Regulation rules, but nobody's going to get hurt by this. And so maybe we shouldn't act. So how much harm is going to come to the patient matters a lot. What's the financial damage going to be because of this? So there's a lot of managerial discretion in whether or when to make these decisions. And I'm blown away still now by reviewers that refuse to believe this. So I'm in the midst of an R&R at MSOM right now on a decision-making paper for recalls, and the reviewer comments, they're actually kind of fascinating. The reviewer's like, I don't understand. This has to do with the CEO's involvement in the recall decision, as if the CEO wouldn't care about recalls. And the reviewer is like, isn't there an organizational process? How can you stipulate that the CEO is influencing these decisions? I don't believe it. And so we're trying so hard to convince them that of course they're involved in these decisions. These are fundamental decisions that affect the material bottom line of these companies. They care about these decisions. There's a lot of discretion in them. It's often contingent upon defect severity. So the more severe the defect, the less discretion there is on whether or not you announce it, but there's always discretion on when. So timing is always an option, but the more severe it is, the less likely you are to hide it. And then regulatory policy also matters. But all recalls have discretion as to when. So Medtronic's a good example. I've had a chance to work with them in my research. I never worked for them. I wish I had. I have a lot of respect for Medtronic. When Guidant kind of imploded, most of my friends went to work for Medtronic. They're like the magnet in the Twin Cities for medical device executives. And so people that I hired are now vice presidents at Medtronic. I'm sure they're making 3 times what an academic makes, but they're doing wonderful things there. And so it's a great company. And I don't think they have this policy right now, but in working with the head of quality at Medtronic in one of my papers, and we were talking about the decision to recall, she's like, I give my teams 3 days. Once they bring to me a potential recall decision, I say, you have 3 days to make the decision, and that's it. Then we're going to decide we're not going to let this drag out. I can promise you a lot of companies aren't like that. And so that just indicates to you how much discretion these managers have. She set that policy with the CEO of Medtronic at the time. Another cool story that just blows my mind that this happened, but my last year in industry, right before I came to get my PhD, we were bonused heavily off of managerial objectives. So my production line had a top 10 objectives. I had a top 10 objective list. And my number one objective that my vice president of manufacturing wrote into my top 10 was no recalls from your production line in the calendar year. And so I looked, she wrote that in, not me. I had written all the others. She added that in. And I went to see her and I'm like, I don't think this is a good idea because this is just going to motivate me to like, this isn't the right an objective. This would incentivize me, and $20,000 or more at stake for this objective. This would incentivize people to hide recalls. Like, you don't want this as an objective. This is the wrong incentive. I don't actually remember if we had, I know she left it in there, and I don't remember if we had any that year, but it stimulates kind of a whole theme of research around incentives. Like, you can be incentivized to reveal quality problems or incentivized to hide them. So this is the one of the gender studies that I mentioned, and it's got a cool story. So Corinne Post, she's a management professor at Villanova now. At the time, she was at Lehigh. She called Katie Wowak, or emailed her, and she said, Katie, I noticed that you do recall research. I do gender research. Do you think there's a story between gender and recall decisions? Katie's like, I really think there probably is. So she emailed me, and the 3 of us started working on a paper. And we realized quickly that the gender balance of the paper wasn't good. We would get into these very personal gender-based discussions over Zoom about how men and women are going to make these decisions differently. I had been in these decisions, so I was kind of adding my 2 cents, but Corinne is a gender expert, and so she would say, well, actually, women and men, they make decisions differently along these lines. So we knew we needed to balance the team out a little bit better. So we added Dave Ketchen from Auburn. He's a management professor. And so the 4 of us worked on this for several years. And we finally got it out. It was a tough one to get through reviewers, but we find some amazing things around gender and recall decisions. To explain to you how the findings of the paper, I have to explain to you how the FDA classifies recalls. So we examine recall counts and recall timing, and we examine how gender influences recall count and timing. The FDA has 3 classes of recalls. A class 1 recall means there's either been or could be a death or very serious harm. Class 2 is what the FDA calls medically reversible harm. I write that in many of my papers, and it just never sounds that nice. I don't know what medically reversible harm is, but it doesn't sound like a good thing. But it's not as bad as death from their perspective. And then class 3 is there's no risk of harm. That means like there's a boxing or labeling problem, something like that. This distinction is a huge part of this paper because what we talk about in this paper is that a class 1, you can't hide that. Like if some people are dying, you're going to have to announce it eventually. But a class 3, you can hide. If no harm is coming, it's a labeling problem. If you don't want to reveal it, oftentimes you can probably just fix the problem and not worry about stuff that's in the market. So we look at 2 aspects in this study. First, we look at counts. And FBR is called female board representation. It's the proportion of your board members that are female out of the total number of board members. On average, I think in this study it was about 7%. A lot had 0, some had 1, a few had 2. So this first finding is, when I remember running this in Stata, and I saw this result, and I was like, oh, this makes complete sense. Based on all the literature at this point that I knew about gender differences, there are a significant increase in class 3 recalls the more females are on the board. You could initially think that just means there's worse quality, but that's not where this class 3 recall count really indicates. This is an indicator of how likely are you to hide problems. These are the kind that you can get away with not announcing. And so what this shows is that the more women on the board, the more transparent the company is in revealing the problems that they're experiencing. They're not going to hide the ones that are hideable. But then we run a regression on time to recall, which is the time from defect awareness to recall initiation. This is how long the firm takes to make the decision. And we get a completely opposite sign, and it's on the completely opposite spectrum of severity. What this means is that the more women on the board, the faster they are going to make these class 1 decisions. So what I mentioned is you can't hide class 1 recalls. People are dying, and no matter what you do, you're going to have to announce it eventually. That's why there's no statistical significance up here. You're not going to get a more or less class 1 recalls while females are on the board, not significantly, but you're going to get them made faster. So the more women on the board of directors, the more women that are leading a company, you hide problems less frequently, and when it's a very severe problem, you make the decision much faster. And to put it into context, when you move from no female directors to at least 1, the class 3 recalls, which are the ones that are hideable, increase by 120%. That's how we interpret that coefficient. And the class 1 recalls are made 35% faster, or about 1 month. 1 month is a big deal when these, on average, it takes about 3 months for these to get initiated. 1 month saves lives. And so this actually is very important from a practical standpoint. And this was going from 0 to some. And in the regression, as you add each additional woman to the board, these results get stronger and stronger. One thing that was difficult for us to get by reviewers here was endogeneity. And so the reviewers said, well, this is a characteristic of the company you're picking up. A company is more likely to move faster to make recall decisions and to add women to the board. You're picking up kind of a characteristic of the company. So we had to get an instrument in the second round to review, and the gender co-author, Corinne, pointed me, I was doing the data on this paper, and she pointed me to some gender studies that have used instruments, and we found this really powerful and really interesting instrument called board female connectedness, and this is how we addressed endogeneity here. And so what this variable is, it looks at every focal firm, and it looks at the men on the board, and it looks at the other boards that they sit on, because board members like this, they sit on multiple boards. So it took the number of the men on a board, it looked at the boards they sit on, and the number of other boards they sit on that had women on the board. So the idea here is the likelihood that I'm a man on a board and I'm going to support adding a woman to my current board is driven by, do I sit on other boards where there's good gender diversity? That's unlikely to be related to whether or not my company has product recall problems, but it's highly likely to be related to whether or not I support voting for a woman to be added to the board that I'm currently on. It's been used in a lot of gender research, and it worked perfectly in this paper. We pulled it as an instrument. It was very highly relevant, and we were able to argue that it was not very related to the dependent variable, but very predictive of our independent variable. You can stop me with any questions you have along the way. I'm just going to touch on a couple working papers that are, this one I think is about to get submitted this week. I don't think you know about this one, Ujjal. Ujjal and I up at the front have done many of these papers we've worked on. And so these are 3 co-authors, Kartik at Minnesota, Katie, and then John from Notre Dame. So John had some political ideology data, and he talked to Katie at Notre Dame about doing a politics and recall decision-making paper. And basically, we have all the political donations of every executive for every medical device and pharmaceutical company in the United States that's publicly traded, and we're able to measure the political persuasion of a firm, basically the ideology of the executives. And we then relate that. We do a very similar study to that gender paper. We look at how it predicts the counts and the times of recalls. And I'll just say it's very predictive. And so your political ideology is very predictive of how you make recall decisions. It's not exactly as we would expect, but I'll leave it at that. It's interesting. So CEO stock holdings and recall decisions, this is another paper that Ujjal is on. And so this is one where we've fought with reviewers on the discretion, the managerial discretion in making these decisions. And so this one it's interesting, it's unfortunate, but the more stock a CEO has in the company, the slower they are to make these decisions because they're afraid of the financial penalty that the company's going to get, that their own personal account's going to get hit. Ujjal does a fantastic job on the methods, and we basically show that not only does more stock slow down my decisions, but that when I make decisions more slowly, the stock penalty on the firm is even greater. And so the title is Bad Things Come to Those Who Wait. So it basically means like I'm waiting to protect my stock value, and by doing so, I'm hurting my own stock value. This one's a couple rounds into MSOM. This one's just about to get submitted. Okay, now I'm going to end with this third dimension, which is recall effects. So I don't know if you've noticed, if you study recalls the way I do, there's certain phenomena you might notice. Auto recalls seem to come in waves. Like when they come, they seem to come all at once from multiple companies, sometimes related to the same issue. And there's actually been kind of popular press about this. Why do recalls come in waves? And so Katie Wowak, one of my co-authors on recall work, she had the idea. We were at a conference several years ago. She's like, have you ever noticed this? And we said, yep, we have. Let's do a paper on it. And so in a marketplace like automotives, it's perfect to study this because cars are very similar. Cars have similar types of defects, and NHTSA doesn't measure severity. And so with no severity recall measure, you're able to either hide or not hide recalls much more easily than you are in the FDA's world. And so that led to this paper. And these are my co-authors. You see several familiar faces here. And we call it hiding in the herd. And we've basically discovered a herding effect in recalls. So what the herding effect means is that 3/4 of auto recalls occur in a cluster. A cluster is, on average, 30 days where there's 1 leader and 7 followers. What that means is when there's been a long period of time where there's no recall announced, the next one that comes triggers a cluster, and people follow quickly. And we're not saying necessarily that this is done on purpose. Some of it could be subconscious. But when a new company announces one, other recalls follow right away. And even after we control for similarity of the problems, that doesn't explain it. What does explain it is a stock market effect. So the leader of a cluster suffers the most serious stock market penalty. The followers don't suffer much at all. In fact, the longer you are away, the closer you are to the leader, the less suffer you do, less stock market penalty you experience. So if it's been like 3 months since there's a recall, then Toyota announces one, you might notice GM will announce one right away, maybe something completely unrelated. They're going to suffer less penalty and less kind of negative attention because of that. So we theorize that followers are trying to hide in the herd to avoid the penalty. The really interesting thing that really confirms the mechanism for me is the fact that when Toyota is the leader, they stimulate the most followers. Toyota has this worldwide reputation for quality. The idea here is that if Toyota's got to experience a problem, nobody's going to blame me if I have one too. And that's the trend in the data is very much consistent with that if Toyota initiates, others follow very quickly. Two quick things that happened after this got published. Our author team first got an email from NHTSA, and they wanted to understand this whole clustering effect. They wanted to understand the statistics. Ujjal did the statistics, so trust me, they couldn't understand it. Ujjal is very, very good when it comes to methods. I don't think all the co-authors exactly understand everything Ujjal did, but NHTSA did not understand what we did in the paper. So we had to explain to them, this is what the Hawkes process model is, which Ujjal used along with many other things. But then we got an email from Toyota. I'm pretty sure I got this email from the head of communications at the Toyota company. Really freaked me out. The email basically said, we've noticed your paper on clustering, and we'd like you to retract it because it's false. I mean, this is already published, right? This is on MSOM's website. I'm like, oh my gosh, forget tenure. It's all over. Like, I'm not retracting a paper. Well, what actually happened is a funny story. So you can't read the paper unless you pay for access through Informs. They didn't read the paper. Notre Dame did a press release when we got the paper published, and probably not a good call. Notre Dame picked pieces of the paper out, and they put it into their press release. Toyota just read Notre Dame's press release. At the very first paragraph of this paper, we're motivating the story by talking about kind of well-known recalls, like Toyota's unintended acceleration recall, that some people died because of that. However, in the paper, because of things like this, Toyota comes out looking very good in this paper. Toyota doesn't follow other people. Toyota's a leader because of their high quality. So they're spoken of very positively in this paper. But the very first sentence talks about some deaths because of this unintended acceleration. That made the Notre Dame press release. As I started emailing the communications head at Toyota, it was clear they had not read the paper. They had only read the press release. And it took a little bit of intuition to kind of figure this out, that this guy was threatening us and he hadn't actually read the paper. And so we basically told him, look, the paper is in the public domain, and the site that we have for these deaths, it's a USA Today or a CNN article. At the time, it was true. What he was telling us is that NASA and Toyota got together to do an analysis to determine that those cars were not actually faulty, that the unintended acceleration recall by Toyota was not needed. So he pointed me to all these NASA engineering articles to demonstrate that they weren't at fault. And they were saying that we were slamming unnecessarily Toyota by saying that they were responsible for these deaths. The reason we didn't get, I think, sued by Toyota is because we were citing valid, legitimate sources in the front of our paper to make this claim. We didn't make the claim up. We cited a USA Today article from 2000 sometime, and at the time it was true, and so he went away, thankfully. But it was very scary to have the head of Toyota come after us. Thankfully, I wasn't the lead author, so Ujjal would have taken the hit, not me. Another one on this is another interesting, I'll fly through this one, but this is another working paper on regulatory agency differences. So I've talked a little bit about mandating and not mandating. NHTSA mandates auto recalls, the FDA does not. And we wanted to do a study to see, does it matter who initiates the recall, the regulator or the company? So we look at gender, we look at who initiates, and we look at trust to see how recalls are initiated. Does it affect how people view the company after the recall? These are my Indiana co-authors, Rod Parker. Ruth is now up at Baruch School in New York, but she was in Indiana when we started this paper. So this is under review at MSOM as well. We have basically 3,000 car owners in an experiment where we present them with a recall, and we randomly vary who initiates it, whether it's NHTSA or the firm. We then create, because under the first round of review, we find a mechanism of trust. And so the department editor said you need to randomly vary trust somehow, control for instrument for trust. So we have two forms of trust that are randomly varied, affect-based trust and cognitive trust. And these are motivated by actual recall examples. Affect-based trust is when the company says, we care about our customers, we care about your safety, we care very much about you. That's why we're taking this action. Cognition-based trust is more, here's what we have found. We've done this research in our products, and it's much more technical. So we randomly vary these two types of trust, and we randomly vary who initiates the recall. We find unquestionably in very large sample effects that customers lose trust in the firm when NHTSA mandates, and this lower trust lowers purchase intention, but it's offset when affect language is used. So if the company tells them, we care about you, that makes a huge difference in the language of the recall. Again, because we have this gender aspect to this research stream, this effect is much stronger for females than for males. This really matters in this context because almost 80% of car buying decisions are influenced or made by females, so it's important for these companies to understand how gender differences are when these recalls are being announced. There's all sorts of implications for NHTSA on how they should be leveraging their mandating power, on the firm on how they should be communicating these recalls, and there's even FDA implications because the FDA chooses not to mandate recalls. And in some discussions that my co-author teams and I have had with them, they say it's because we have good relationships with the firms and we do soft mandating. When we call them and say, you know, we think you need to take some action on this device, and so the company will recall and you won't know that the FDA really was behind it. And so the implications for the FDA are that they're losing a chance to drive down consumer demand for poor performing companies. And we know the FDA has in their eyes some companies that they really do not like. In the close work that Ujjal and some others have had with them, they bring up company names that say this is a bad actor, and they're losing a chance to kind of influence market demand by not actually publicly mandating recalls when they could. So now I'm going to close with this little discussion on regulators. So I've kind of come up with this chart that's a summary of how these three regulators kind of play off each other on these categories. Whether or not they have the ability to mandate legally a recall, whether they actually do, the transparency of their recall timing data, how well they relate with industry, their political power, and whether or not they inspect facilities. So when it comes to mandating, all three of these regulators have the ability by law to mandate recalls, but only NHTSA does. And so FDA and CPSC is so disorganized, they wouldn't have the ability to really do this very well. I kind of am critical of them in many of my papers, but I think it's important because there's a lot of products that the CPSC regulates, and they don't do a good job regulating them. NHTSA does mandate, FDA does not. FDA has fantastic recall timing data. What I mean by that is they tell consumers, they tell anybody who does a FOIA, Freedom of Information Act to the FDA, when the firm first became aware of a defect and when they decided to recall. That's how we can study recall timing in FDA markets. NHTSA has that data in very rough PDF format that we've had to scrape. It's very hard to get this from NHTSA. CPSC has none of that data. When it comes to relationships with industry, FDA has very good relationships with industry. They know the senior VPs of quality at these companies. They have relationships with them, and they act on those relationships. NHTSA, because they mandate, companies don't like NHTSA very much. There's very much an aggressive relationship between NHTSA and companies in general, and there's only a few companies in the automotive industry anyway, and they don't get along very well. CPSC, not only do they not have a positive one, they don't have a negative one, they just don't have one with companies. There's just so many consumer product companies, and the CPA's leadership is so divided across multiple commissioners, they don't do very well when it comes to relationships. When it comes to political power, I think the COVID experience has kind of heightened everybody's awareness. The FDA is very much a political actor in the world. They have a lot of political power. They use it fairly well. People usually know who the FDA commissioner is. They have relationships with Congress. So their political power is pretty strong. NHTSA, not so much, but they're an important regulator. There are certain congressional committees that know who the NHTSA commissioner is. CPSC has very poor political leverage in Congress. When it comes to facility inspections, the FDA is the only one that regularly inspects facilities. This matters a lot if I take you back to the very first paper I talked about. These inspections are a part of the recall decision-making process where they get into the company and see what the quality level is. The FDA is the only one that does it. NHTSA doesn't come to plants, neither does CPSC. This is in the tutorial paper. At the very end of this tutorial paper, we talk about the differences between these regulators and why it matters. And these differences have really stimulated several papers, actually, when it comes to understanding how they operate, why they do. So several of us had this really nice opportunity to work very closely with the FDA. And I want to talk about them, a little bit about the differences between an FDA grant and an FDA contract. So Ujjal and I and several people, Yvonne's here. So Yvonne and Ujjal are here. And several other people, it's the only one I put my face on just so you could see that I was actually a part of this grant too. John and I, John Gray at Ohio State, had the unfortunate pleasure of being co-principal investigators of this beast. It was very, very, a lot of work. Not something you want to do unless you're tenured, because it's going to take a lot of time. But the 12 of us, or how many it was, got a chance to do an FDA contract, and most of us also got a chance to do an FDA grant. And these are, did I get your school right? Okay, good. I had to look this up, actually. But these are the schools represented by this work. So just the logistics of managing a cross-university grant or contract. This was, the grant was $30 million. We were a small part of that. The contract, it was just us, and that was about $2 million. And if you've ever wondered where that money goes, like what is that money used for? It disappears into overhead in universities' kind of grant offices. It's used a little bit for research money, and it pays faculty some summer money, but none of us got millions. None of us even got thousands. It was really just a way to pay for the overhead to administer a grant at university, where a lot of the money went. So the purpose of these projects was to help the Center for Drug Evaluation and Research predict drug problems and drug shortages. So I'm going to kind of tell you very briefly the difference between a grant and a contract, and then a little story that explains these differences. So these are two ways to work with the federal government. From a funding standpoint, they're both great sources of funds. These funds can pay for doctoral students, they can pay for summer pay, they can pay for your research account, your RATS account. You can put money into that. So you can use this money to do lots of things. When it comes to interacting with the regulator, the FDA interaction was okay. We would have quarterly meetings with them, and I would say in general they weren't that interested. It was something that the CDER did because it was probably on someone's annual performance review to manage a grant to help us understand drug problems, but I wouldn't say we got a lot of interest from them. When it comes to a contract, you get more interaction than you probably want. You are actually a federal contractor of the government. So the people on that team, we all had government IDs. We had government laptops, government access passwords. We had to get background checks done because they were giving us proprietary drug data. It was intense. And so we had multiple weekly meetings. Instead of quarterly meetings, each of us on that picture led a team. Our team would meet weekly. The broader team would meet weekly. I have maybe 3 or 4 people at the FDA that I know very well now because I got a chance to meet with them weekly for 2 weeks. A lot of access to regulators. When it comes to access to data, this part's kind of really interesting that I didn't know. In a grant, you're not going to get any government data that your average person in the public doesn't have access to. So if the data is not something that a researcher could FOIA, get a Freedom of Information Act request on, they're not going to give it to you, even though they have it. A contract, you're basically a federal government employee. So we could go into our FDA laptops, and we could get into the FDA intranet, and we could look at almost anything. Like we had an unbelievable amount of data, and we had also signed all these forms that said we'd agree to go to jail if we ever used this data without permission from the FDA. And so it was almost intimidating how much data they gave us here. And our thought going into the contract was this is going to be amazing because we're going to publish so many papers that uses this data that nobody in the world is going to have. That's the only reason we did the contract to begin with. And that ties into my last bullet, which is academic freedom. When it comes to a grant, the FDA and federal agencies have absolutely no say over what you publish. They support the funding. You need to give them credit in the publication. They have no say over what you do with your findings. It couldn't be more different in a grant, in a contract. You actually work for the federal regulator. They gave you the data. They have full rights on what you publish and what you do not publish. And so I'll just tell one quick story here that was, it really came to a head where we considered going to the Wall Street Journal and New York Times because it was such a difficult situation. Some people on this team and I, unfortunately I was involved in this one as well, we had done a drug shortage study. And this goes back to the inspections. So the FDA does inspections. If you think about the baby formula shortage up in Michigan, right? The FDA had gone in, they had found a lot of problems. All of a sudden, baby formula is on shortage. That wasn't the motivator for this paper because that happened after we started this study. But the intent of this study was that we want to look at FDA inspections and future drug shortages to see if somehow your inspections, which are so hard, are causing shortages. Now, the people that we worked closely with on the contract thought this was a great question because these were non-political scientists, they were PhDs, and they were really good friends of ours. So the FDA collaborators thought this was awesome. So awesome that they put a person on the paper. A PhD expert in natural language processing. She was part of the paper. And we found some incredible stuff. So basically, and so in the midst of this paper, they said, not only do we like this question, but we're going to give you access to a special inspection score that the public doesn't even know about. So the very first slides, I showed you 3 inspection scores: official action indicated, voluntary, and no action. Well, there's a 4th one, and it's a downgrade from official to voluntary. And it's something that the FDA does to prevent shortages. And they told us this. We didn't know this existed. They said, we have this downgrade score. We do it in case we think a plant can't handle an official action indicated. And I've received official action indicators at Guidant. They're incredibly hard. Like, it's pages of things that you've got to do. Production kind of does shut down while you're working on these things. So they have this downgrade score, which is there if they think this company is a little bit susceptible to problems. Let's not give them an official action indicator. Let's downgrade it. To us, that kind of validated the research question, in a sense. If they have this score, this is a validation, this is a great question. So we put that into our predictive model. We got these great findings that showed that, yes, in fact, when the FDA gives an official action indicated, that plant is much more likely to experience a shortage in the next few months. But when they downgrade them, they're much less likely. That downgrade has a very powerful effect on the likelihood of a shortage. We had a paper written, we had a slide deck, and our collaborators at the FDA said, okay, this has gotten a lot of attention at the FDA because the paper had been sent around to very senior people. And they're like, we want you to present to these 3 people. And I didn't know their names. I looked them up on LinkedIn. They were very senior people at the FDA. So I led the presentation. It was all over Zoom. This is all during COVID. John Gray, Gopesh, myself, I can't remember who else was on the call. And we weren't 5 minutes in, and one of these very senior people just starts coming after us very aggressively. Like, this, of course, this can't be true. Do you understand statistics at all? And so they started and I was looking up this person's background on LinkedIn, and he had like a bachelor's degree in history, and all of us had PhDs, right? We all understand statistics pretty well, but he was the political head of this branch, and he basically said there's no way the FDA is causing shortages. All we do is find the problematic plants. You're just picking up some unmeasured, and he was using, to his credit, some proper terms. He was basically saying, like, you're picking up some endogeneity here without using that word, that these are bad plants. And we're just giving bad scores to bad plants, and bad plants have shortages. You're just not measuring the fact that these are bad plants. It's kind of a valid comment. This paper is now under review, and we've done a fantastic job, I think. We pulled in an author that did a great job on instrumental variable analysis. We're instrumenting for that badness, and we're still finding some really good results. But the end of this story is that these very senior people at the FDA said, there's no way you're submitting this to a journal. You work for us. This doesn't make us, they literally said, this makes us look bad. Why would we submit a paper that makes the FDA look bad? Now, we had an FDA co-author on the paper, right? So they certainly were going to let the FDA co-author be on the paper. But, I mean, the things they said to us, I just wish we had Zoom recording on, because it was the kind of thing that would have made press, and an editorial in the Wall Street Journal would have gotten some of these people fired. They basically said, you're not allowed to submit this. This is our data, and we will not allow you to use this data in this paper because it makes us look bad. That was really the only reason. So the contract's now over, and we FOIA'd pretty much all the data. The only thing that we couldn't FOIA was that downgrade variable that I talked about. But the head of the FOIA office called me when I asked for it. I said, I want the downgrade measure from official action indicated to voluntary action. It was like asking for something that's top secret, right? You're not supposed to know this exists. So the head of the FOIA office emailed me and said, I'm not sure what you're talking about here. Can we talk? They've hired a new FOIA head right now at the FDA. She's just fantastic. I've had many phone calls with her. So we did a phone call. I'm like, yep. So I'm actually on a contract with the FDA, and I want this downgrade measure from official action indicated to voluntary action indicated. So like at first I demonstrated that I know this exists because on my government computer that I can access right here as I'm on the phone with her, I can see this measure. I just can't download it off my government computer because then I go to jail. And so I didn't do that, and I don't want to go to jail. And she's like, well, we can't give that out. That's not FOIAble. That's not, public can't get that variable. So in the end, we found a way to somewhat tell the same story using publicly available data. But to me, this is why you lose academic freedom in a contract. This is why I'm never doing a contract again with the federal government. It ended, unfortunately, it ended very badly. The grant ended very positively. This ended very badly because they got to choose what papers got submitted and what didn't. At the very end of the contract, we had all these papers written, and they were the final decision maker. Yes, you can submit I think one paper they allowed us to submit. The rest of them, are you on that one paper, Yvonne? So one paper got it. And it was Yvonne's paper, and it only told fantastic stories about the FDA. It made the FDA look like a champion of public health. Yvonne was on it. Yvonne was probably smarter than me. I was out to look to kind of find something controversial, and everybody was observing this on our grant team. And so all the papers that came after that, like, okay, don't make the FDA look bad because you won't get the paper out of it. So Yvonne's paper makes him look good, and I don't know how the paper's doing under review, but at least he got permission to submit it. So I'm going to skip over these final slides because I only have 5 more minutes, and I want to make myself available for questions. Are there any questions before I end?
So I'll go around here. If you have a question, then you raise your hand, and then you'll be able to be part of this discussion, which is being recorded.
Which is unfortunate. I hope I didn't get in trouble.
Okay, well, thank you. That was extremely interesting, if only because the Toyota anecdote kind of shows just how much practitioners read our papers. But I was wondering if you could comment on, let's say, the differences that go into decisions between making device recalls and drug recalls. Is that kind of the same thing, or are there different things at play there? A drug is very different from a device. So I would maybe naively assume that maybe there's different thoughts that go into that process, or maybe you could just quickly comment on that. Thank you.
That's a great question. So I've only made device recall decisions, not drug ones, but I've studied drug recall decisions, I think probably more than medical device ones. So I'll just give you my quick opinion. So the thing on drug recalls is they have this whole idea of side effects that is not existent in medical devices, right? A medical device, it's either going to work or it's not working. But, as you know, drugs like Vioxx can do things that the drug never intended it to do. And these companies have to wrestle with these side effects in a way that is not present in medical devices. The other thing that's different in drugs is these compounds are shared across so many other drugs, right? Devices are unique in a lot of ways to the firm. But like if acetaminophen starts performing poorly, how many companies are in trouble if acetaminophen is a bad compound? And so the generic status in drugs affects recalls quite a bit differently. And some of us are a big part of a generic drug recall paper that we've been wrestling with in management science and now at MSOM, and it's a product of some of these grants where generic drugs and original drugs do not behave the same, even with the same underlying compound material, because they can be manufactured differently. So the shared materials in drugs, the side effects make decisions differently. But then when it comes to the managerial decision, the FDA manages them identically. You have a firm awareness date, you have a recall initiation date, you have oversight by the FDA, you have inspections. So from the FDA's perspective, it's really not that different. In fact, they have recall data analytics groups at the FDA that oversee both. So I think the decision is kind of done the same. Hopefully that helps a little bit. Yeah.
Thank you for your talk. It was very, very interesting. And the question that I had was, have you all done any work with respect to looking at the consumer perspective in terms of recalls? Because I know most of the examples, which were really good that you mentioned, were kind of based on the, I guess, like the company's perspective.
Yeah. Right. The one consumer study that I probably went a little fast on is this experiment. And it's there's a huge opportunity to study consumers better. This is one of the few that I know about, and it's basically the consumer response to who initiates the recall. Is it the regulator or the firm? How that affects my trust in the company, how gender plays into that relationship, and how trust plays into that relationship, and my likelihood of repurchasing again from that company. That's one paper. I don't really know of any others.
I was going to say, do they also do any work with respect to looking at from the, and this is still consumer, but you mentioned you all did a lot in terms of female, male, so gender.
Right.
But in terms of like marginalized groups, even to the previous question in terms of drug recalls, like looking at those different populations and trying to, you know, utilize that data to also help to see who's actually kind of like using those type of drugs and things of that nature.
Yeah, that's a great question. That's a paper waiting to be written. I think what I hear you saying is marginalized parts of society that are more likely to use a certain drug, do companies pay less attention to? That's a paper right there. That's a great paper. No, I haven't done that because I haven't thought of it, but also to understand, I know there are different disease states by different demographics, right? So you'd have to first kind of identify these are the right diseases that are differ by demographics, and then see how recalls, the speed is different, or the likelihood of that. It's a great point. You should write that paper. Somebody should.
By the way, the composition of the board, can you look at the diversity there?
Yep. So the problem there, we've done that, is there's just not a lot of data on that. There was hard to get the gender data. I do have board diversity data. I have minority indicators on boards. There's just not enough variation at this point. Hopefully that'll change soon. And maybe even today that's different, but this is archival data, 20-year-old data, and there wasn't much back then.
Well,
thank you very much.
Thank you very much. Very stimulating.
Thank you.
And please remember that eventually this recording will be online, but if you really want to delve into the details, bookstore here at Informs, or get a hard copy. Thanks for being here, everyone. And thanks again, George. This was fabulous.